Okay, day 2 of section 1 in chapter 9 is on graphing not only just singular coordinates, but now we're going to start graphing equations. Okay, so we have our basic polar coordinate grid. You can use one grid for these next few problems. They want us to graph some of these simple equations. The first one that you'll see here is if they set the radius equal to 2. Okay, similarly when we graph on the rectangular coordinate grid, if we have x or y is equal to a value, we find all of the points that contain that value and it forms a straight line. But on the polar equation graph, if we looked at all the points where the radius was 2, let's see, that would be right here. This has a radius of 2, and this point has a radius of 2, and this point has a radius of 2, and this point has a radius of 2. So all the points that have a radius of 2, if I was to find them all and connect them, you can start to see that if I just start plotting all of them, they form a circular shape. And so when we don't have theta in our equation and just the radius, we're going to form a circle. And so you can do this as best you can. I'm going to cheat here and use a tool to draw a circle. We're going to have a circle with its center at the pole and a radius of 2. Okay, so that is a graph of the equation r is equal to 2 in polar coordinates. Okay. If we have an equation like this where theta is equal to pi over 6 or some sort of degree, now we need to find all of the points where the radius doesn't matter, but all the points that have been rotated pi over 6 degrees. Okay, well, let's see, pi over 6 degrees would be the same thing as 30 degrees. So if I go to the 30 degree spoke, that would be this point, 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 this point. And if you think about it, if we have a negative radius and we rotate it a positive 30 degrees, that would give me this point, this point, this point, this point. And so you start to see that when we have just the theta established, that creates a straight line. And so I'm going to go ahead again and cheat and draw my straight line right on the 30 degree spoke, both in the positive direction and in the negative direction. Because remember, technically, if we have a negative radius, these over here would be positive 30 degree rotation as well from this side of the pole. Okay, so this would be the equation theta equals pi over 6. Okay, very similarly, try these two on your own. Okay, so there's our circle with radius 3 and our line of all the points where the angle of rotation was 2 pi over 3. Okay, the last thing we're going to learn in this section is how to find the distance between 2 points on the polar coordinate. This formula is called the polar distance formula. It's the square root of r1 squared plus r2 squared minus 2r1 r2 cosine of theta 2 minus theta 1. So given two coordinates, r1 theta 1 and r2 theta 2, you can plug those into this formula and find the distance between the points. This formula may seem complicated, but you may have also recognized that it's very similar to the law of cosines. And that's because that's exactly what it is. It's just the law of cosines. The law of cosines said that a squared equaled b squared plus c squared minus 2bc cosine of angle A. Okay, now obviously this was for a triangle and we're dealing with some coordinates instead. But if we think about it, what we're trying to solve for is when we have two coordinates on our graph. They gave us an example here. If we had a point here and a point way over here, if we use the origin as a third coordinate, we can actually create a triangle out of this. So when I connect these two coordinates and connect them with the origin, we create a nice triangle. And we know a lot about this triangle because we know the coordinates. Because I know the coordinates, I know that the radius of this coordinate, r1, is actually side 1 of my triangle. And r2 over here, that's actually r2, the other side of my triangle. And because I know theta 1 and theta 2 over here, those are my coordinates, I can figure out the angle between them if I do theta 2 minus theta 1. And so you'll quickly see that we have a triangle here with side given, angle, and side given. Side, angle, side, triangle. And we're trying to solve the distance between the 2 points, which is this coordinate over here. This would be our big X that we're trying to solve for. And so if we're trying to solve for A over here, that's why we square root both sides. All we need to do is plug in radius 1 and radius 2 for my two sides of the triangle. And theta, the angle in between them, is the difference between the two angles of the coordinates. Okay, so that's called the polar distance formula. Really, it's just the law of cosines rewritten. So let's go ahead and apply it. We have a word problem here. This one describes an air traffic controller who's tracking two airplanes that are flying in the same altitude. The coordinates of the planes are A, 5, 310 degrees. So if I start at my pole and go out 5 units, 1, 2, 3, 4, 5, and then rotate 310 degrees, I'm going to speed that up and go that 310 degrees is actually negative 50 degrees. So this would be 15, 30, 45. So a little bit past here. Okay. This would be plane A. And then plane B is at the location radius 6 out from the pole, and then 345 degrees rotated. So again, instead of going around 345, I'm just going to go backwards 15 degrees. So B would be right here. Okay, so we're going to sketch a graph of this situation. And again, since they want us to know regulations prohibit the airplanes from passing within 3 miles of each other, they want to know if the airplanes are in violation. So if we sketch this out like a triangle, we can use law of sines, or really our polar distance formula, to figure out how far apart these two coordinates are. Okay. So let's see here. The radius for B was 6, so the side of the triangle over here is 6. The radius for A was 5, so the radius of this triangle, or the side of this triangle, is 5. And now I just need to solve for the angle in between them, which means I need to find the difference between 345 and 310. The difference between 345 and 310 is 35 degrees. So whether you want to think of it as solving this triangle now or using your polar distance formula, it really doesn't matter. So I'm going to go ahead and plug in my numbers. I'm looking for the square root of 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of the angle between them, which was 35 degrees. And so this becomes a calculator problem at this point, and then we can see how far apart the two coordinates were. Okay, I got 3.44 units, which was in miles, because they said the distance is measured in miles. So 3.44 miles. So those planes are actually not breaking any regulations because they're more than 3 miles apart. Okay. That's it for today's lesson. Make sure you check Blackboard for the assignment that corresponds to this lesson, and I'll see you guys later.